Hi class, and welcome to week 5. Next week, as you know, in spatial analysis we have a lab test, and so what I thought would be the most efficient use of our time for this lecture video is to, for one, go over the skills that we have learned so far in a summary, and I've got that right here, this summary document, and I've put it in the Lab 5 folder, and two, to actually demonstrate these skills using ArcGIS. So for the summary skills, projections and coordinate system manipulation, so we know how to determine what the coordinate system is and the difference between project define and project. Number 2, calculating the spatial extent, which relates to the projection and coordinate system. Creating a file geodatabase and the subsequent data set and feature classes that go in that. We can add fields, and once we've added fields, we can calculate the spatial geometry, or we can use the field calculator, and we can calculate values based on that. We can also use summary statistics for those fields. We can use the identify tool, and we can select records in the table, and we can select records from the view. And once we've selected records, we did this in week 1, we saved them to a separate shapefile. We can use the measure tool and measure distances on the map. We can launch into 3D viewing and do the vertical exaggeration and set the 3D scene. Zoom in, zoom out, create bookmarks, put labels on, and also use the definition query to limit the labels, and we can convert the labels to annotation. Using the field calculator, as I mentioned before, saving selected new records as a shapefile, and a whole lot of symbology in map production. So what I've got here is an empty ArcMap document, and I've got several layers. Probably what I'm going to ask you to do is to copy a file and then unzip it. And once you unzip it, you can see that when you add these layers, there's contours, eskers, lakes, there's a study area boundary, vegetation, and surface. And so the surface isn't showing up because the study area boundary is drawn over top, and so there's our surface layer, and this is a raster. So we can take a look at each one, and we can look at the properties, and if you go into general, you know that you can set the layer name, you look at the source, top, bottom, left and right, and you can tell from these values, for 1 it has the DD, meaning decimal degrees. For 2, you can see that you've got a negative value here. And for 3, you can see that because these are small numbers, that they're probably not referring to UTM coordinates. If you look at the data source, you can see that the geographic coordinate system is GCS North American 1983, and the angular unit is degrees. So we're pretty sure that this layer is in latitude, longitude. Also, if we run our cursor over the map, you can see down at the bottom, right here, down at the bottom, that it's showing in decimal degrees. Now that was the first layer that we added to the data frame, and so all things considered, if we open up the properties of the data frame itself, we should be able to see that the data frame, the coordinate system for that is the same. So let's just see what the other ones are, because we know that we can't count on them all being the same even though they all show up, because ArcGIS will project on the fly. And so let's look at eskers. I'm going to right click, go to the properties. These also look like they're in decimal degrees. Lakes, go into properties, decimal degrees again. Vegetation, go into properties, decimal degrees again. The surface, we'll go into properties, a little bit different here with the extent, but you can see that it is these numbers again, decimal degrees. And the study area, let's look at the properties of the study area under the source tab, decimal degrees. So what we can do here is if we turn all of these layers on, I'll turn them all on like that, and I want to zoom to full. Well, that certainly is one way of determining which one of those layers has the largest spatial extent. You can see right off the bat that the vegetation layer has the largest spatial extent. Right here. Whoops, sorry, turn off the surface and the contours, and you can see that it has the largest spatial extent. Now, calculating the spatial extent is quite difficult if you've got a layer that is in decimal degrees. And calculating area, length, perimeter, any of these geometric features is very difficult to do if the layer is in latitude, longitude. And so what we're going to do is we're going to project all of these layers. Now, what I'm going to do is I'm going to insert a new data frame. And the new data frame is going to house all of the projected layers. So I'm just going to right-click, double-click that, and I'm going to call it projected. And right now there's unknown units, there's nothing on it. And this one, the old one, I'm going to double-click and I'm going to call this raw data. And I'm going to call it GCS for Geographic Coordinate System. Another thing I'm going to do is I'm going to save my project under Map Document Properties. I want to make sure that I store relative path names. And I also want to just resave my map. So right now I'm going to activate this layer and I'm going to add the toolbox. And I'm going to run a projection on all of these layers. So that is under the data management tools and projections and transformations. Now when you open this up, you have define projection, create spatial reference, create custom geographic transformation, convert coordinate notation, and one of these we've used before, and it's this one here, define projection. Now, should you be using this in this instance? Well, what I'd like to do is I'd like to convert the data that I have from latitude, longitude into UTM. And I happen to know that this data exists in Zone 17, and if I look at the data, again, if I go into properties, I can see that the North American datum is 1983 that it's using, and so I'm going to project it into UTM NAD 1983. Now, but answering the question, should I be using the define projection tool? Well, define projection is a tool that you would use if none of this information showed up. So if you go into a layer and you right-click and you go to source and it says no coordinate system defined, or if you look up here and there are question marks, and then what you need to do is you need to actually create this information, this coordinate system information. Another way you can do that is if you went into Art Catalog. And in Art Catalog, you can look at a different layer and you can determine whether or not it has what kind of spatial reference it has. In that case, if there is none, then you would use the define projection tool. But bear this in mind, the only thing that define projection does is creates this information. It does not turn these top, bottom, left, right, X and Y coordinates, it does not turn them into metric UTM. It does not perform a transformation. When you want to convert data from one coordinate system to another, you do not use this tool. Instead, what you use is, depending on whether it's a vector layer or a raster layer, you would use, this is for vector, you would use the project tool. So I'm going to project the contours. So my input data set, and actually great thing here, and you know, honestly we haven't spent too much time with help, but if you look at the help for any of these, you can see projects spatial data from one coordinate system to another. And you can see the shape change here, just like you did for the Ontario data. This would, this kind of looks the same. It's flat and sort of stretched out, and this one is more upright and compact. And if you go to the tool help, it gives you further information about this. So what I'm going to do is I'm going to choose, oh dear, I'm going to choose contours. The input coordinate system, it's already there, and the reason it's there is because define projection has already been run, so there's no reason to run it again. My output dataset or feature class, look, it wants to save it as, it wants to save it in the default geodatabase. We do not want to do that. So where we're going to save our stuff is in, I'm going to actually save this stuff in spatial analysis. Uh-oh. Well, I'm back. So the problem with that was, and this has sort of been a consistent problem that we have had with ArcGIS, is to do with the security settings with a browser. And so you're wondering, how does ArcGIS and the browser go together? Well, all of these tools launch in a browser window. And if you have on your computer set your browser settings so that the security is high or medium high, it will not allow certain ActiveX controls to run on your computer. And one of those ActiveX controls is this window. Where was I? I was actually saving this not to the default geodatabase, but I'm going to save it right to the C drive. Fleming, to my spatial analysis folder, and to week 5. And the name is, I'm going to call it Contour UTM, and that gives me an indication of what that is. So the output coordinate system that I'm choosing is projected. I'm choosing the UTM system. I'm choosing NAD 1983. And I'm choosing Zone 17 North. I say OK, and this geographic transformation does not come up, and that's because I'm not switching from one datum to another. The datum is 1983 in the original, and I'm still maintaining that 1983 datum, so I just say OK and let her run. So aside from that little tiny error that we just had, you can see that I have added this layer, Contour UTM, and I'm going to drag that down. So what I'm going to do is pause this presentation. I'm going to project all of these layers one at a time, and then I'll return. So what I've got here are all the projected layers, and once they have been projected, I just dragged them down into this new data frame and deleted them from the original one. Also, I did not project the surface layer, and we don't actually have to project this for the purposes of anything that we're going to be doing for our test. And so sometimes what I like to do is just sort of minimize that data frame, and it's a good practice to always keep your raw data separate anyways, and so it might be a good idea for all of your raw data to make a copy of it right off the bat. So I'm just going to resave. I'm going to activate this, and you can see here's all of the layers that I have. Dragging surface down to the bottom, and if I zoom to full, there we have it. So if we go back to the summary of skills, project define using project, calculating the spatial extent, well, that's something that we can do now, and we can do that because we've actually projected the data, and so it's just a simple matter of calculating the difference between the top, bottom, left, and right, and you can see that we've got some nicer numbers to work with here. And so basically the top is the maximum y, the bottom is the minimum y, left is the maximum or the minimum x, and right is the maximum x. So calculating the spatial extent then is just calculating difference between top to bottom and left to right. Creating a file geodatabase, feature dataset, and feature classes. Well, doing this, we use our catalog, and it's very simple. You right-click on the folder where all of your data is and go to New, File, Geodatabase. It puts a default name up there, and I'm going to change this to Test 1. And I don't need the GDB extension because it's going to put that there for me. So right-clicking, I can go to New Feature Data Set. Now remember, a feature data set, if you look at the icon, you see 3 squares, and so that's a set of data. So if I click on that, I can create my feature data set, and I'm going to call it Data Set 1. And choosing the coordinate system that will be used, well, what I'm going to do is I'm going to choose the coordinate system that from the layers that are currently on there. And so I've got 2 coordinate systems. I've got GCS North American 83, and that is my surface, and I've got NAD 83, and this is the one that I'm actually going to choose. And you can see that I've got 1, 2, 3, 4, 5 of these layers. Now, which one has the largest geographic extent? Well, clearly you can see that the vegetation layer does, so I'm going to choose that for the spatial extent. There is no vertical extent in this situation because we aren't looking at Z coordinates for this data. We're just looking at X's and Y's. The XY tolerance is generally established by default, and it generally sets this based on it looks at what the unit is for the data and the X and Y extent. Generally, I don't know if I've ever changed the tolerance. Now, I suppose you would change it if you were working for a survey company, and you would probably want your tolerance to be greater than it is set to currently. And then if I finish, you can see that I have a data set 1, although there's nothing in it yet. So right-clicking on this, I can import. I can say I want a new feature class, and that way I would be creating my own, but it's much easier just to import your feature classes. So I have several here, contours. By default, it's going to put it in the geodatabase and in the feature data set that you have created. The output feature class, you can call it the same thing that the shapefile was, and away you go. Okay, so the difference between these two, I've only done one. So if I right-click on this one and I go to Properties, I can see that the shapefile, it's a shapefile as the data type, shapefile feature class. And if I look on this one, I can see that the data type is File Geodatabase Feature Class. Now the difference between the two, once something is in a file geodatabase, or any geodatabase for that matter, you lose the ability to be able to add fields and calculate feature geometry. Well, that's just one of them. Now you gain a bunch of other functionality, so it is a trade-off. We're not at the point yet where we're creating topologies where we demand the stability of a geodatabase. Right now we're still in the pre-processing stages. So although my geodatabase, I have created one data set, feature data set, and have one feature class. I'm not going to be using them. But what I will do is I will insert a new data frame, and I'm going to double click on it and call it geodatabase, and say OK, and I'm going to remove this one from here. And if I want to add the data, I can just grab the data set and bring it in. Now, if I grab onto a feature data set from a geodatabase and drag it into the table of contents, I bring all of the feature classes with it. So at this moment, I only have one in there. When you will be creating more than one, and rather than having to drag them all in, you can just drag in the one geodatabase, or sorry, the one feature data set. So let's go back to the Word document, and the next thing is adding fields and then adding records to fields. So I'm going to go back to where my shapefiles are, and I'm going to activate this. And how about what we're going to do is we will open up for the eskers. So we've got a few eskers, not too many, and I'm going to symbolize them to be a thicker symbol so that you can actually see where they are. So if I right click and I go into the open the attribute table, I can see that this data came from 040P11. This is NTS. So this is the we have a 31D7, and this is 40P11, and so this actually came from the National Topographic Database as well. So you can see probably a few familiar fields. These are the fields that you symbolize on, and you've got an accuracy. Well, that's something that you should have already figured out for your assignment. I was asking you to come up with the accuracy of the NTS data, and there it is right there, plus or minus 10. So what I want to do is I want to actually calculate the length for these, and you can see that there isn't a length field. So the first thing that I'm going to do is click on the table options, and I'm going to add a new field. So the field that I'm choosing to add is length, and what kind do I need? A short integer, long integer. Short is 255, long is going to be 32,687 or something like that. Float, double, text, date. Well, I would like there to be some decimals, so I'm going to choose a float, and I'm going to choose, let me see, a precision of 10 and a scale of 5. Now what this means for the precision is that this field will allow 10 digits, including the decimal in that field, and the scale means that it will allow for 5 decimal places. So I'm going to say OK, and I'm just going to expand this a little bit here so that we can see it. And so how do I calculate the length? Well, I will right click on this field, and I've got two options, the field calculator. So if I use the field calculator, I can do something like this. Well, I can say length is equal to, well, I could actually put in a value here. I could put in 100 and say OK. And every single length is 100. So I could just pick some of these records. So I'm going to pick one and hold down the shift, 2, 3, and then I'm going to right click on this field and go back to field calculator, and I want to make these 500. And if you look, well, it will only work on the selected records, but that doesn't really give me what I'm after. What I'm after is calculating the length. So if I right click and I go to the calculate geometry, then it will prompt me with, well, these are the most common ones. And if you think about it, it knows already that it's a polyline. How does it know that it's a line feature? Right there, because that field says polyline. So it knows it can't calculate an area, but it can do length, and it can do the midpoint and beginning of the line. So I want length. I would like it in meters, thank you. And it says calculate selected records only. Well, I've got 3 selected. Better uncheck that, or else it'll only do the ones that are in blue right now. So I say OK. Yes, I want to proceed. And so there is my length. So if I go back to my summary of skills for the lab test, we're at number 5 here. So adding fields and adding records to the fields, calculating spatial geometry such as area and perimeter, and the last thing I have here is using summary statistics for fields. Before I go on to that, what I will do though is I will choose another layer, lakes for instance, and I'm just going to zoom to this layer. Here's my lakes. If I right click and go into the attribute table, let's see what we have. We have a centroid X and a centroid Y. Water body there, you can see that it's the same NTS sheet, and I do not see an area field in there at all. So how could I find out which is the biggest one? You can see that there's 0 out of 72 selected down here, and so I can click on this one. Now there's 1, now there's 2, now there's 3 selected, or I can clear the selection this way. So what I'm going to do for these 73, 72 records is I'm going to create a field for the area. So if I right or click on the table options, add a field. The field is named area. Again, I'm going to choose a float, and I'm going to choose again maybe 12 and 5. Not sure how big that field needs to be. Right click, calculate geometry. I'm going to choose area, it should be the default, and away we go. So now that I've got these records, you can see that I can, boy, there's a couple of them that are really big, and then there's a couple that are really, really small. And so if I right click on the field itself, I can sort either ascending or descending. So if I sort descending, then you can see that I've got the largest records on top. So I'm just going to minimize this a little bit, make this a little smaller. Where are my lakes? There they are. So if I click on this top one, which is the largest area, I can see that it's selected both on the map and in the table. And there's another one. And look at all of these. I can select them all. Well, that pretty much gets most of the really big ones, but there's another one here, right there. But boy, oh boy, what if I had 50,000 of them? I surely wouldn't want to go through and select each and every one of them like that. Well, let's just take a look at some of these numbers, 38,000, 102,000. So what if I said, I'm going to clear this, and instead of just selecting them that way, maybe what I can do is I can query. So under the table options, I can select certain records by composing a query. Okay, so just like the field calculator, it will create an SQL statement. So in this case, how about I will say area, well, let's get the unique values. Let's see what we got. Oh boy, we got lots of them in there. Let's say I want only the records that have an area that is greater than, let's pick one of these big ones here. Well, maybe I'll just put in 100,000. 100,000. Notice I don't have any commas in that at all. Commas are a surefire way to make any SQL statement crash on you. So I can verify this. Yep, it's good to go, and I can apply it. And you can see that it grabs those records. So I've selected some of the records, and if I move the table out of the way, you can see that I've got those records selected. Now maybe what I'd like to do for those selected lakes records is I want to convert them. Maybe I want to symbolize them in a certain way. Maybe I only want to show those. For example, maybe I want it to be a definition query. Well, let's clear this and I'll close the table. Maybe I only want to show the records that for the lake that are large enough, and those little itty bitty ones like this, we don't even want to show those. So let's open this up, open up the attribute table, or sorry, the properties for lakes UTM. I go into properties, and here's my definition query. So the query builder, look at that, it's exactly the same thing. So what I can do is I can say, well, it was area greater than, and I think we put in 100,000, so 100,000, verify it, and you don't really need to verify it, you can say okay, and then I'll apply that, and look at that, I've only got those records that are showing. Now, does that mean that the other records are gone? I've only got 14. How many did I used to have? 72. Does it mean that they're completely wiped out? No, they're still there. What it means is that they're hidden. And so that's one of the benefits of a definition query, that that these records are hidden from you, and you can work with just these. So I'm going to undo this definition query. I'm going to take it off, just delete it here, and say apply. And I've got them all back again. So I'm going to go back and perform this same query, select by attributes here, and area is greater than 100,000, and apply this. You can see that I've got 14 out of 72 records have responded to this query. I'll close the table down. Now, what if I wanted to make a whole new layer? We did this in the week 1. If I right-click on it and I go to Data and Export Data, I can create a whole new layer. Now, you can see that it will try to call it, try to give it a name. If you you probably want to click on this box and ensure that you're in the right location. Well, I'm certainly not. I'm in something called LBL data. So I'm going to go back to week 5. No! I'm back. I'm having trouble with ArcGIS on my computer. So I'm going to have to remember to save often. So I'm going to call this Big Lakes UTM, and I'm going to save this and say OK. And yes, I do want to add the exported data to the map. Again, I'm going to save this in case I crash. And so if you look, I have a different spatial extent for something called Big Lakes than I do lakes. So this, if I right-click on this layer, Lakes UTM, and I zoom to layer, that's what I get. If I right-click on this one and zoom to layer, I zoom in even further. And if I look, open up the properties, you can see that under the Source tab, if you were to do the math, you would be able to see that I've got a smaller extent here than I do right here. So what we've covered another one, which is selecting records and saving them to a separate shapefile. And so using summary statistics for fields, so that's what I'm going to try to do right now. Again, I'm going to save and save often. So if I right-click on the Big Lakes that I've just created, it doesn't matter which one, and I've got 14 of these records selected. Well, what if I would like to know what the standard deviation for the area is? If I right-click and go to Statistics, what it will give me is a frequency distribution, a nice graph. Gives me a count, minimum, maximum, the sum, mean, and standard deviation. Oftentimes you want the total area, so you would want the sum. Sometimes you want the smallest lake, sometimes you want the largest lake, and so minimum, maximum, and sum are 3 probably very useful ones there. So we have covered summary statistics. Let's look at measuring distances on the map. So if we go over, we should be able to use the measure tool. Now, what if the measure tool is grayed out? What happens in that situation? Well, I'll show you. If I go to insert a new data frame, you can see that I have no measure tool. And the reason I have no measure tool is because, number one, I got no data on there, but also number two, if I go into properties, I can see that I have unknown units for my display and for my map. So how is it supposed to be able to measure if I have unknown units? And so if that tool is ever grayed out, that's what you check for. You right click, you go into properties, and you look at what your units are set for. So the measure tool, very easy to do. You look here, you can go to planar, geodesic, loxodrome, or great elliptic. In this case, we are looking at a 2D planar coordinate system. That is what UTM is, so we are going to be measuring distance, planar distances. And here, there's distance or area. And in this case, we've only measured distances, and that's all I would get you to do. So I might ask you to measure from the, the top of one polygon to the bottom of another. And in that case, as the crow flies, you're looking at 1,800 plus meters. Double click to stop that. And while I'm here, I might as well use the Identify tool. I can use the Identify tool and click on a certain feature. And you can see that you can identify from all of the layers that are available to you on that view frame. And in this case, it's big lakes that I'm asking you to identify. And what this does is it gives you absolutely all of the information for that particular record that you have selected, the information from the table, and it also gives you the location that you've clicked on. If you look at how I'm clicking all over the place, and you can see how that value changes, so that might be really useful. Here's a little island right up here. What is the location of that island? There's a little one right down there. What is the location of that, if you can get right on it? Which I'm having a little bit of difficulty doing that right now. So there's the Identify tool. So we can measure distances. We can use the Identify tool, 3D viewing. Well, I'm going to save that one for the end, actually. Labeling features, creating bookmarks, using the field calculator. We've already done that. Saving selected records as a new shapefile. We have done that as well. So let's look at creating bookmarks, zooming in and zooming out, and just general navigation. So I'm going to zoom right to the full extent. And that's the full extent. And the reason is because I've got the vegetation layer on, and that's how big it is. So I'm turning that off. If I only want to zoom to the extent of lakes, I can right-click on this layer and zoom to that. I can also click on the contours. There's the contour layer. There's the eskers layer. I think the eskers actually has a larger extent because, yeah, there's a few eskers up here. Again, I'm going to symbolize those so that we can actually see them a little bit better. And well, let's say that I would like to create a bookmark, and that bookmark is a zoomed in version of this esker right up here. And I would like to save that bookmark. So under bookmark, I'm going to create one. I'm going to call it Esker 1, and perhaps this is an esker that is of primary importance for your project. You can say OK, and then later on you can zoom to that. So if I zoom out to full, there's the full extent, and then I go to bookmark, and then you see that you can just zoom right in. So once I have saved this bookmark, what I can do is copy to the clipboard. So under Edit, copy the map to the clipboard, and then if I go to the layout view, I've got a few things going on here, and I can just say Edit and Paste, and there is the bookmark. There's a duplicate right over there that I'd created earlier. So that's the beauty of a bookmark, is being able to just save and capture one particular extent. Now, saving it the way we did, that it means that it's a graphic only and it's no longer georeferenced. So if we go back to, we've got creating bookmarks that we've accomplished, and let's look at labeling features now. So let's say that if I go back to my data view, and I'm going to turn off big lakes, and I'm going to turn off the, I'm going to turn off the the lakes themselves, and let's say that I want to actually give myself, I want to label the eskers that are in view. So maybe I'll zoom out, or I'll zoom to the extent of the eskers layer, turn off the contours. And so if I right click, I can go into properties, and under labels you can see that the length is what we actually want to label by. By default, it'll look for something, it'll look for an ID, or it'll look for a name, entity name, anything with a name in it, it'll usually try to label it by that. And sometimes you have to change that, so I can apply and OK. And where are my labels? They're not showing up. The reason they're not showing up is because I haven't turned them on. So if I right click and label features, that actually turns them on. So I'm going to zoom into these. And the placement isn't great in this, so I'm going to go and adjust them. And I'm going to make the symbol a little bit larger and apply, and still I'm not really happy with the placement. So if I convert these labels to annotation, storing them in the map, what I'm doing is I am creating, turning the labels into graphics. And from then, I can manipulate them. I can manipulate them individually or as a group. So I will convert these. The overflow means that these are ones that have that were too close together and they overlapped, and so they were not actually added. So you can just close this. So here I can grab this label and I can move it around. I can double click. And I can change any of these numbers. Maybe I only want just one decimal. And I'm going to move this one too. And the nice thing about it is that if you go to Edit and you can select all elements, you are actually selecting all of the graphics that are on the map right now. So now if you had other graphics, they would all be selected as well. But this is one way of doing it. You can also shift click and get two of these, right click and go into properties, and then you're actually adjusting the properties for more than one. I can make the color red if I like and say OK, apply and OK, and that applies to just those two. So we have labeled the features. Now I want to look at some symbology and map production. We've certainly done a fair share of this. What I'm going to do is I'm going to zoom to the layer Big Lakes and turn that on. I'm also going to turn on the contours, and this is the extent of the map that I want. I can also adjust this scale. I want to adjust it to 1 to 25,000, and that's the scale of the map that I want to capture. And so if I go into my layout now, you can see that there's already a grid already added to this. I have added this previously. There's my bookmark that I can put on. If I zoom in, and you know that there's different toolbars that you can zoom in using, there's the layout toolbar and then there's the other one. And so I'm going to zoom to the full page here. You can see that I've already got a grid on. And if I click the properties of that grid, and I can adjust some of these properties. Now, a new grid, if I wanted to add a new one, would it be a graticule or a grid? A graticule, if the data was measured in latitude, longitude. Measured grid is the one that we use if it is in UTM. So the intervals, maybe I want to set it to 1,000 by 1,000 meter intervals, and maybe I want a border or a neat line, and I can remove the old one, and I've got the new one. I can apply that. So the thing that I'm going to be looking for are these numbers. Whoops, these numbers right here. And it's important that you find out how to get those off in properties. Whoopsies. There's my grid, and if I go into properties, I'm still selecting the frame here. Oops, hang on a second. Whoops, cancel. There we go. Let me just zoom to the full page. There we go. So if I right click here, go to properties, oh my goodness, I'm not getting in there. It just wasn't in deep enough. So there's the grid. If I go into properties, I can go for the labels, the additional properties. I can establish the number format as being significant digits or decimal places. Maybe I only want one decimal place, maybe I want none. And I will definitely tell you how many decimal places there is. So I'm going to save this. And if I go back to the Word document, the last thing that we have to look at is the 3D viewing. So the 3D viewing, there's a couple of things that you have to enable. One of them, right click, and you need to add the 3D Analyst toolbar. And the other, under Customize, is, and you can also add the toolbars under Customize, but you have to make sure that the 3D Analyst extension has been activated. So I'm going to launch into Arc Scene. Now they still haven't found a way of being able to click and drag a layer from Arc Map over to Arc Scene, or at least I haven't found out how to do that yet. But you can copy. So what I'm going to do is I'm going to use this surface layer. I'm going to right click and I'm going to copy this over to Arc Scene and paste that layer. Now once that's in there, there's a couple of things I want to set. You can alter the symbology just like you would with any in Arc Map. So I want to set my transparency to 20%. I want to, now your base heights. The base heights refer to where it's going to get its elevation values from, and you want it to get the elevation values from the surface map itself. And then, boy oh boy, we've just lost our map. So I'm going to right click on properties and calculate the vertical extent, and I should get it back. And so now the vertical extent is, the reason that we use a vertical exaggeration is because often the east to west, north to south, or planar extent is much larger than the vertical extent, and so we have to exaggerate it a little bit. Now recall this layer is in measured in decimal degrees, and so for that reason, if you're wondering why you saw the vertical exaggeration being a very, very small number, it's because it's actually calculating in radians instead of meters. I can change this to 4 if I wanted to and give myself a huge, perhaps not, there we go, look at that. Now maybe that's a little bit exaggerated. And so there we are. I have covered everything that is going to be on the test. I think the best idea for you to do is to go over all of your portfolios and just do them again, and follow along with this video. And I'll see you next week. Best of luck.